All right, so we have a couple homework questions from 7.2 descriptive statistics. And Zoom, and 12 and 13. All right, so given the data set here, calculate the summary statistics for you, and then I ask a few questions about checking for outliers. So we didn't cover all of this in class last time. So we covered how to use the mean and the standard deviation to find outliers, but I didn't yet go over how to use the 5-number summary, the interquartile range, to do outliers. So I think what I'm going to do is take all of this into a spreadsheet and just recalculate those numbers for fun. Do I even need to do that? No, I got another example we'll do in a minute in a spreadsheet. So I'm just going to use what I see here. Where's my notebook? Screenshots. So I'm going to do a little more than what this problem asks, just to explain why I'm doing what I'm doing. And this is in section 7.2 in the book. Pen's still warming up here. Come on. There we go. So 7.2, this is homework number 12. And we want to look for outliers in this particular data set, anything that seems unusually large or unusually small compared to the rest. And we are going to first use the 5-number summary. And it's always helpful to do a graph of that. So I'm going to make a graph of that. It's called a box plot. So to make a box plot, we need a number line. And then we have to be able to go from the min to the max on the number line. So 14 to 40 is what we need to do here. And let's see, that's a span of, let's say if we went 10 to 40, that'd be a span of 30. So if I put, say, 10 right here, I could go 10, 1, 2, 3, 4, maybe that's 20, 1, 2, 3, 4, 30, 1, 2, 3, 4, that should work out okay. 2, 4, 6. Now let's see, 40 here, 2, 4, 6, no, that'd be, oh, maybe I should do 5 in between, that'd be easier to count. Okay, sorry, I'm gonna redraw that. Pick a scale that is not too big or too small. 1, 2, 3, 4, 5, we can count by 2. 3, 4, 5, 30. There's 40. And then I just want to mark off, I'll do that underneath my min Q1, median Q3, and the max. So 14, so 10, 12, 14.2. It's going to be just over a little, maybe right there. 16, almost 17, so 2, 4, 6, 8, 7 is right in between there. 17.9, looks like I should have made my scale a little bigger. And then, let's see, 18.7 be about here, and then 39 be way out here. And I guess a bigger scale would have been nice here, because now my box plot's a little tight. So the box always goes from Q1 to Q3, and then the whiskers head out from there. So this would be a box plot for this data. Sorry, it's a little crammed. And then what we do to look for outliers is we take this distance, the width of the box, that's called the IQR. And see, I didn't recalculate that for you, so we would have to find that. So for us to find the IQR, we would want to take Q3 and subtract Q1. So 18.725 minus 16.975 to get the width of that box. So if we subtract we get 0, and then 5, and then 7, and 1. So it's pretty narrow width. 1.75 is the width of that box. What we then do with the IQR is we take that width and we multiply it by 1.5. So we make it 50% bigger than what it is. A calculator might be nice there. So again, this width, I make it 50% bigger, and then I extend that out this way, and I extend that back that way. And that draws these two lines. In between is what we call usual data. And then outside of that is unusual, outliers. So, calculator. And so for this set, we have 1.75. Hopefully I did the subtraction right. I guess I better double check that too. 18.725. Minus 16.975. So there's the 1.75. Then we make that 50% bigger, so multiply by 1.5. All right, so that gives me 2.625. So that bigger part, 2.625. And that's how we look out to each side. So this number on the right is going to be whatever Q3 was, plus that 1.5 times the IQR. And this number on the left is going to be whatever Q1 was, but we look to the left. So minus 1.5 times the IQR. And this right here is that 1.5 times that. So 2.625, easy thing to do is add on our 18.275. So that gives me 20.9 on the right. And on the left, we just do a subtraction. So let's see, what was Q1? 16.975. And minus that 2.625. So I get 14.35 on the other side. So anything less than 14.35 is considered unusually low. Anything greater than 20.9 is unusually high. So if I look back at the data set, they're in order. So this number right here is unusually low compared to the rest. And anything bigger than 20.9, so that would be these last two here. So this one and this one, these are unusually high compared to the rest. Back on the question, I'm asked to state what the IQR was. So that distance was 1.75, and then I was to use it to find the lower and the upper bound, that 1.5 IQR rule. So what were my numbers there? They were 14.35, and I think it was 20.9. And are there any outliers, yes or no? I found 3 of them, so I would definitely answer yes there. And then the standard deviation rule, reminder about that. Standard deviation rule, let's see, let's take this from the page so it doesn't get too messy. Looking for outliers, checking out the spread of the data. Whenever we have a distribution of data, so let's just draw in a kind of a smooth curve for it instead of a jagged histogram. The mean is roughly in the middle, so that's the X bar. And then what we do is we make these lines on each side to try and contain 95% of the data. The estimate on how to do that is from the mean, add 2 standard deviations to the right, and then from the mean, subtract 2 standard deviations to get to the left. So we make these 2 calculations. So for us, the upper one would be 18.7 plus 2 times 4.81, and the lower edge of what's usual would be that same 18.7 middle minus 2 times 4.81. So we find those 2 numbers and then look, are there any numbers less than that? That's the unusual range on that side. Are there any numbers greater than this right here? That's the unusual set of numbers on that side. So the IQR rule and the STD rule don't always agree, but for the more extreme values, they will. And it just depends on the data set. Every data set's different. So calculator. So 18.7 was my mean, plus 2 times 4.81. My upper limit was anything above 28.32. My lower would be start at the mean, and subtract 2 standard deviations. .08. So notice there's nothing below 9.08 up here in the data, but 28.32, there is 1 number above. So according to the 2 standard deviation rule, I called that the 95% rule the other day, there is 1 outlier. So 1 measurement is unusually high compared to the rest using this rule. Okay, so that's 1 homework question. 13.
Yeah, I'm pretty sure 13's the same.
Yeah, it's the it looks like I posted the same thing, but this time I didn't give you the numbers, so you have to come up with them. Is the only difference on this one right here. So I kind of ease you into it. I give you the starting point and you make the calculations. Here we do it all from scratch. So I'm just
do it all in a spreadsheet, right?
Yeah, so I would just do this on a spreadsheet. So this should copy into a spreadsheet nice. So let me bring up a new spreadsheet to copy this into. And when you copy from a web page to a spreadsheet, just be careful not to copy too much. So beginning of the first number to just at the edge of the last number. And then it should, on a good day, paste in. Yeah, that goes in there pretty good. Get a little more readable. And then I'll put my summary statistics over here. So the usual summary statistics we calculate are the count. How many are there? Deviation. So the mean and the standard deviation go together. Count's just always good to have. And then the next group would be the min 1, median, and we just call that lowercase m, 3, and the max. And then we'll use that second group to calculate the IQR. Other numbers we sometimes calculate along with those of the range. So instead of what's the distance from the min to the max, make a little space there. So count is just count. This question I don't think needs it, but have it. And then autofill is not a good idea here. Mean is average. Standard deviation. STD, we want .s for sample. That's important. Then min is just min. Quartile, either just the plain quartile or quartile inclusive. We'll never use the quartile exclusive. And that needs two things: the data and which quartile you want. 0 through 4. The options, we want number 1, the end of the first quarter. Median. And we don't need the median for this problem, but I always like to have the box plot just for visual representation. Quartile 3. So it's always data, comma, which quartile do you want? We'll talk about this in a minute, but a quartile and a quarter, two different things. The range, which is a measure of the spread of the data, what's the distance between the smallest and the largest? That's always just max minus min. And then the IQR is the width of the box, so Q3 minus Q1. With a problem like this, I usually like to draw a number line showing the box plot and then marking off where the edges are for outliers. And a histogram is kind of nice too with the mean. And rounding, these go to 1 decimal place, so the usual rounding rule is go 1 more place. So I would round these to 2 decimal places. Based on the IQR, right, we can get the lower number and the upper number. The lower one would be Q1 minus 1.5 times the IQR. So it's always good to put a label about what the number means. And then the upper is always Q3 plus 0.5 times the IQR. And then make the calculation. So lower one, Q1 minus 1.5 times the IQR right here. So anything under 7.4-ish is unusually low, which we don't have. And then the upper, Q3, make sure you click in the right spot, plus 1.5 times the IQR. So anything above 27.1, and oh, these numbers did not come in order, did they? Well, that's annoying. Okay. So one thing we could do is just look at the min and the max, or we could sort these numbers. It's hard to sort them in in 2 columns, unfortunately. We have to rearrange them, but that's not too bad. I'll show you a trick for that. All right, so let's see. The boundary for the lower part here, 7.4 is less than the min. The min's the lowest number, so there's nothing lower than that edge. And then 27 is below the max, which means at least the max is bigger than that there. So according to this, the max would be unusually high, be an outlier. IQR rule. So I think I want to copy this. So I want to get these other numbers here first. For the mean and the standard deviation, we have a couple numbers we can do there. That would be the mean minus 2 times the standard deviation, and then the mean plus the standard deviation. Standard deviation just has the letter S usually. Those also before we go draw a picture. So mean minus 2 times S then the mean plus 2 times S. All right, so again, we have a number that's less than our minimum, so there's nothing unusually low here, but there is at least one number above 29, right? The max is above. So this is unusually high also according to the IQR. Is there more than one? We would just have to search the list looking for anything above 29. So I'll show you the trick to putting these in order. I would do it this way. I would highlight the data, and then I'm just going to do a Control X on the keyboard to cut that data out. And underneath here, I'm going to paste it back in, but when I paste it back in, I'm going to paste it special and I'm going to transpose it, which is going to turn rows into columns. So now I get them vertical. Then all I do is take the second column and move it under the first. Interestingly, didn't cut. So let's make, oh, I guess it's a good thing I didn't cut them because I need those because that's where these numbers came from there. So let's just highlight this different. All right, so that's the original data. Here's the data in a vertical list. And then I just want to sort that. So data, since that's the only thing I selected, I can just sort A to Z. Oh, no, that was not what I wanted. I want data sort range. Only what I selected needs to be sorted, not the whole sheet. There we go. So now they're in order, smallest to largest. So there's the only thing bigger than 27 was the max, and the only thing bigger than 29 was the max. Yeah, so there's only one outlier here, and both methods agree on it, which doesn't always happen. All right, so spreadsheet on the homework.